Hello everyone, today we're gonna learn about priority queue data structure. This tutorial is a part of the data structures and algorithm class. Priority queue mimics a queue of things in real life with different urgencies. The more urgent of the element, the higher the priority. A practical example like in this picture is a queue of patients at the hospital emergency room. A person who was hit in the head, who also has a broken arm and a broken leg, will require the highest attention of the doctor. With 3 different serious injuries, the doctor probably have very little time to save him, so that's why his priority is high. It's urgent. The second person in line broken her leg, but the wound is not as life-threatening like the first person, so her priority is lower. The third person in line only have a scratch in his arm. His injury is the least severe one, and he has the lowest priority to get in the emergency room. That is how priority queue works. Each element in the queue has its own priority. So the element represents as a pair. The first thing in the pair is the data of the element, and the second one is the priority. In our queue, 1 is the highest priority. So in a priority queue, the higher priority element gets out first. Like this person in the line, he has the most serious injury. Hence, he has the highest priority and he will get out of the line and get to the emergency room first. Elements with the same priority follow the first in, first out rule, FIFO. So if we have a priority queue with all the elements had the same priority, then our priority queue behaves exactly like a normal queue, first in, first out. Example applications of priority queues are everywhere and we're using it every day. For example, your router Wi-Fi network bandwidth management, or your computer time management. Like the computer will decide which program in the queue is allowed to use the CPU for how long. Priority queues also has only 2 operations, NQ and DQ. NQ will consider data with priority and put it in the queue. For example, this element with data B and priority 2 will be inserted between 1 and 3 element. For DQ, the element in front of the queue will be removed, just like the normal queue. In this example, element with data A and priority 1 is removed from the queue. An element with data C, priority 3, is moved up in front of the queue. Next, we're gonna build priority queue data structure. There's a lot of approaches to build priority queue data structure. The approach we're doing is a naive one, which is not the most optimal solution, but it's simple and easy to understand. Our priority queue class looks exactly like the same, a normal queue. The only difference is the enqueue method. So we create a priority queue class. We use an array to keep track of our queue. Our enqueue method will have the time complexity O(n). But if we use the heap data structure to keep track of the queue, it's gonna give us O log n. I will briefly go through the implementation. So when we enqueue, if the queue is empty, we're gonna add the element to the queue and we're done. If the queue is not empty, we go through all the existing elements and we check the priority of these elements. Then we add the element right after the existing element which has the same priority. Then we mark that we already added the element and we stop the operation. But if the element we're adding has the lowest priority, that means that we didn't add it between any elements, so our added flag remains false. And if this is the case, we simply put our element at the end of the array. When we finished, we return the element. The rest of the method is just the same with what we have with the normal queue. DQ to remove the first in line, sign to see the queue size, peek to see the first element in line, and print to see all the data in the queue. Now we're done and we can create a priority queue. We instantiate a new priority queue and we print it out. And of course it's empty for now. Next we're gonna do operations on our data. The first operation is insert, which is enqueue. We enqueue element data C at priority 3. We enqueue element with data B priority 2. And if we print it out, element with priority 2 is in front of element with priority 3. This is the front of the queue, even though element with priority 2 is enqueue later. If we enqueue an element with priority 1, because 1 had higher priority than 2, so this new element will be put in front of 2. As we can see here, A1 is now in front of the queue. If we enqueue an element with priority 4, 4 has the lowest priority in this queue so far, so it's gonna be put in the end of the queue, just like it's here when we print it out. If we enqueue a new element with priority 2, this element will be put behind the existing 2 and in front of 3. And that's exactly what we see here. To delete, we dequeue. The first element in the queue will be removed. In this case, that is A1. And if we print the queue out, B2 is now in front of the queue. So if we pick, we're gonna see B2, like it here. And if we check the size, we now have 4 elements in the queue. So the size is gonna give us 4. Next, we always remember how fast our operations are. The speed of insert and delete in priority queue depends on the way how we implement it. Normally, people will choose heap data structure to implement this, and the average of time complexity of these operations are O log n. Different implementations will give slightly different time complexities. Some implementations has O1 in insert and ON in delete, or vice versa, meaning O1 in delete and ON in insert. So I'm putting the average here. But remember that in your application, you can choose a more suitable implementation, which is best suited for your application. There's no access and search operations for priority queue. That is all for today's tutorial. Thank you for watching, and I will see you in the next video.